Okay, I figured out what I've done wrong right here. My s of x is a positive. I knew I was doing something wrong because it should give us the same answer. See, it was 3x to the third times x to the second, which gives us 3x to the fifth. Well, now I plug in my negative 1, and that gives me negative 1 to the fifth power is negative 1. So now 3 times negative 1 is negative 3. Sorry about that. Okay. I gotta figure out if I'm turning my page or flipping my page because I had them stapled together. Suppose the functions f and g are defined as follows. Okay, so we're going to divide. Okay, so originally our domain, because then it talks about domain. Okay, find all values that are not in the domain of f of g. There's more than one. Okay, so here's the deal on this problem. It's really weird how they ask this question, but I'm not used to it. All right, so right here, we're not doing anything wrong. We're not dividing by 0. We don't take a square root in either place. So our domain is all real numbers, okay? Just so you know, because we'll go over this, this is all real numbers. Same thing with this one. There's no rules. We're not breaking any rules. The rules that we can't do, we can't divide by 0 and we can't take square root of a negative number. Well, when we go to do this, this means take f. You can do this two different ways. I'll try not to mess this one up. Okay, so we can do this x plus 7 over x minus 6, x minus 1, and now plug in our 4. And so we have 4 plus 7 over 4 minus 6 and 4 minus 1. Okay, so on the top we get 11. On the bottom we have negative 2 times 3. So we get a negative 11/6. Okay, that's one way to do it. The other way is you can find your f of 4, which is the same thing that we were doing. So it'd be 4 plus 7, which is 11. Then you find g of 4, which is 4 minus 6 and 4 minus 1. And that's going to give us that negative 2 times 3. And then which gives us negative 6. Now you take 11 and divide it by, now you do f of 4 over f of g of 4, I should say. So that would be 11 over negative 6, which still gives us the same thing. You're doing the same thing. And that's what I was trying to do on the other problem that I messed up on. Okay, find all values that are not in the domain. Okay, that means what are our restrictions here? Okay, here, because it's division, now we have to worry about restrictions because anytime you're dividing by 0. So here, it's going to be 6, and here, x can't be 1. If you were solving. We weren't solving, okay? And that's what they were asking. They were asking for what values are not in the domain, and that's what you'd say. If they asked you for the domain, you would put it in order. Okay. Open circles, everything that way, everything between it, everything that way. It's if they asked for the domain. They didn't, but just in case. It would be negative infinity to 1, parentheses, 1 to 6, and 6 to infinity. And I ran out of room. But that would be the domain if they asked you for that. Okay, now they've given you, I'll try not to make any more mistakes. We've got two functions here. Find the value of r of s of 5. Okay, so here's what you want to do. You want to find this s of 5 first. Okay, you want to find that first, so you come up here and you find s of 5. So you take out your x, you plug in 5 squared minus 1. Be careful because that negative is not part of the squared problem. That square only goes with the x. This is like saying negative 1 times that. So this is going to give me 25, but because of that negative, it gives us negative 25 minus 1, which gives us negative 26. Okay. So now what you do is you find r of, we're replacing this with our answer of negative 26. And now you plug that up here, you put a negative 26 right there. 2 times negative 26 plus 1. Whoops. You get negative 52 plus 1. And you get negative 51. Alright. Right here at 38. Suppose suppose the functions q and r are defined as follows. We have a q, we have an r. Alright, when it's written like this, sometimes these are going to be x's. Okay? But because they're 2's, here's what I would do. I would find this first. Then when you get that answer, you plug it in there. So what I would do is I would find r of 2 first. So I take my r, wherever I see an x, I plug in 2. That gives me negative 10 minus 4 gives me negative 14. Okay, so I'm going to take the negative 14 that I got right there, and now I'm going to plug in that negative 14 into q. So I'm really finding q of negative 14 now. So I take my q, say 2 times negative 14, which gives us negative 28, minus 3 gives us negative 31. Okay. Now, here, again, the easiest way is to find q of 2, get that answer, and plug it into r. So, q of 2, I'm going to take my q function and plug in 2 wherever I see an x. 2 times 2 is 4. Minus 3 gives me 1. So now what I'm going to do is I'm going to take out this and I'm going to replace it with 1. So I'm really finding r of 1. So I'm going to say negative 5 times 1 minus 4. This gives me negative 5 minus 4 gives me negative 9. And that should do it.